2.4 Congruent Triangles Part 2, SAS, ASA, SSS. Today we're going to be able to write conjectures about what we need to know in order to prove that two triangles are congruent. With a warm-up, it says use a protractor and a ruler. Draw triangle ABC with these measurements. Segment AB is 5 centimeters long. I'm going to label that A, B. Check. Segment AC is 2 centimeters long. Now, if I just randomly draw 2 centimeters coming off of A to make AC, I don't know at what angle it wants me to use. But if we look down below, we've got our angles that we need to use in order to get this triangle. So from angle A, I need a corner that's coming off of it at 40 degrees. So I'm going to line my protractor up. I can see that it's 40 degrees right there. And then it says that that length at that angle A to C, is 2 centimeters long. I'm going to label my lengths. This is 5 centimeters long, and then I drew this angle as 40 degrees. Now, right now, all I've drawn is 2 side lengths and 1 angle, and then I can connect up, this is C up here, this was AC at a 40-degree angle. I can connect up C and B, and if I connect those two together, you can see that that length between C and B is 3.7 centimeters long. Now that was kind of the gross length between the 3 side lengths. So we used the 5 centimeters, we used the 40 degrees, and we used the 2 centimeters. Now we could have drawn this triangle by drawing the 20 degrees off of angle B, but look, if I did this correctly, that angle measure that's coming off of angle B is already 20 degrees. So right now, the minimum amount of information, let's answer the question, did you use every piece of information to draw the triangle? No, the answers will vary. We used 2 sides and an angle. Now the question says, what do you think is the least amount of information required in order to build 2 congruent triangles? Now in the room, if everybody's following this warm-up, no matter what, if we use these pieces of information, we're going to make the same triangle. But between you and your neighbor, if you did the 5 centimeters and the 20 degrees, and then the 3.7, would you still build the same triangle? And the answer is yes. So in the world of triangles, congruent triangles, you don't need all 6 pieces of information. I don't need to know all 3 sides and all 3 angles. You only need 3 pieces of information. And the ones that we're going to focus on today are side, angle, side. That's what the S and the A and the S stand for. We're going to look at angle, side, angle, and side, side, side. So SAS is side, angle, side. ASA is angle, side, angle. And SSS is side, side, side. So the first one we're looking at is SAS. Now, if we were doing this in person and live, if I was present, we would take a separate piece of paper and build a triangle ABC given this information. And then we would cut that triangle out and compare it with other people in the room. For time's sake and for note-taking sake today, we're not going to do that. We're just going to imagine that we do that today. And we're going to take this triangle and just build it right here onto our notes. So AB is a side, angle A is an angle, and AC is another side. So this is going to be a lot like the warm-up. It says side angle side AB is 8. I'm going to put that down kind of in the bottom of my box here. So that's AB, and that's 8 centimeters long. Then they want us to build angle A coming off of that at 55 degrees. So from angle A, line it up on A, and we want angle A to be 55 degrees. So between 50 and 60, there's 55 degrees. But then they want AC to be 6 centimeters long. So when I hold this up at the 55-degree angle, I want to come up to 6 centimeters. I really should have done my 55 in a different spot. And that's C. And then if we close it up, do we actually even really care about how long CB is? We don't. All we needed to know was that this was a side with an angle in between and another side. So this is our side, this is our angle, and this is our side. Something that's important about this is that the angle is what's called included. Is included or between the two sides. Included. I know that doesn't look very good there, my writing, but that's that it's included. All right, let's take a look at angle, side, angle. Angle, side, angle. So now we've got an angle A, a side of 8 centimeters long, and another angle of 45. So let's try to start with the side length because that's where we're going to build off of. So I'm going to put that 8 centimeters down at the bottom again, which represents AB. Again, even though that wasn't the first piece of information listed, I started with my side. But now I can build angle A at 60 degrees. There's angle A. And then angle B is at 45 degrees. Slide it over, 45 degrees going this way. Now, do I know how long either of those lines are? I don't, but if I draw a length that's longer, going in both directions, you'll get an intersection between those two, and that intersection up top is going to be your point C. So here's our 8 centimeters, our 60 degrees, and our 45 degrees. And now we've created this congruent triangle between all of us of ABC with an angle, a side, and an angle. This time, the side length is included. Between the two angles for angle, side, angle. The side is in the middle. All right, our final one, we need 2 rulers for this one. It says, use 2 rulers to build this triangle. We've got an AB of 12, BC is 10, and AC is 8. So it's all 3 sides. We have no angle measures to work off of. So let's build the longest side first, 12 centimeters. I'm going to build it down here at the bottom of the box so I can give myself some room. So that's our AB, 12 centimeters. And now using 2 rulers, AC is 8 centimeters. So I'm going to put my ruler kind of upside down. So I'm going to 8 centimeters off of A, and then I want B to be 10 centimeters coming off of B. Now what I'm going to do is I'm going to line my rulers up so that the 8 and the 10 cross. Let me pull my hands away so you can see this. Let's see if I got it kind of nice. Right there. So now coming off of A, I've got 8 centimeters right there up to 8. And then off of B, I'm coming up to 10. So I'm going to put my finger right there, make a little dot so that I can, oh no, make my little dot, and then I'll draw my let me draw my 8 centimeters first nicely. Sorry, my other line got a little crooked. So that's 8 centimeters on that side. And then let's draw this side length nicer. Oh, it was off just by a little. Yeah, my intersection was just a little bit off, but that was pretty close. We'll see if you can do a little bit better than I did. But you should get a 12 and an 8 and a 10, and I need no angles. I can make all the same triangle using side, side, side. All right, let's try and look at one that does not work. One pattern that does not make congruent triangles is the pattern of angle, angle, angle. If I build a triangle that's got 3 angles that are the same size between them, you are not going to make congruent triangles. So let's look at this one. 2 different students built 2 triangles with the following information. Angle A is 143 degrees. Angle B is 21. And angle C is 16. Well, that's true. You could use your protractor to measure. And it says, did they fulfill the requirements listed? Yes. Yes. And we could check with a protractor. But are the 2 triangles congruent? No, they're not congruent to each other. What's happening between these 2 triangles is that it produces not congruent figures, but similar figures. It's a dilation or a similar figure between the 2 triangles. So angle, angle, angle is not what we call a congruence pattern. All the things that we were learning on the other page, those are called congruent shortcuts or congruence patterns for saying that 2 triangles are congruent. So let's try these examples. Match each statement using only the information shown in the pairs of congruent triangles. So let's look at this first one. I can see on this first one that the only information they gave me between the 2 triangles are tick marks. And tick marks represent sides. So I like to use little S's to write that. So this side length matches to this side length double tick mark matches to this double tick mark, and this triple tick mark matches to this triple tick mark. And I can see that between these 2 triangles, the information that I know about them is side, side, side. All right, now this one, I've got an angle. I'm going to use an A to match this angle. And I've got another angle that matches this angle. And now between them, they have what's called a shared side. So that's our S that's in between the 2 angles. So you can see the order that they go into: angle, side, angle, where the side is included in between. So that matches A for angle, side, angle. Finally, on this one, this tick mark is a side that matches this single tick mark that's a side. I've got a double tick mark that matches the double tick mark, which is a side. And then I can see that the angle is included between them. So as I go around my triangle, it's a side, angle, side, an SAS, which would be B, SAS. Number 2, what is the least amount of information that you need to conclude whether CDE is congruent to triangle PQR? In this case, all I have so far is a side that matches a side and an angle that matches an angle. So the first thing that you could do is, if you wanted to go for angle, side, angle, you could add that angle C is congruent to angle P. You could match these 2 top angles in order to make angle, side, angle. Or if you wanted to go for side, angle, side, which is the one that some of you might have seen sooner, that would be that side length DE is congruent to side length QR. So this is an OR. Angle, side, angle, or side, angle, side. All right, so our last one here, it says prove that triangle ABC is congruent to DEC, and then find the values of X and Y. So right now I've got a side, and then a double tick mark side and side, but what we're lacking is either a third side or some type of included angle. The included angle that we can add here is that ACB, so angle ACB, is congruent to angle DCE. And those two are across from each other on a diagonal, and that's what's called vertical angles. And now we can set up some equations now that these two triangles are congruent to each other by side angle side. So the triangles are congruent by side angle side. If that's true, then now we can set some equations up. So I can see that 4y minus 6, the single tick mark, is equal to 2x plus 6. And then my double tick marks are congruent to each other. A 3y plus 1 is equal to 4x. Now I have two variables and two equations, which means we need to use a system of equations in order to solve this. And the way that I'm going to set this up to solve it is to use elimination. So that means my x's and y's need to be on the same side and my constants need to be on the other side. So first thing I'm going to do is I'm going to try to get my 6 to join my other 6. So I'm going to add 6 to start. So then I get a 4y equals 2x plus 12. And then I'm going to move my 2x over to the other side. 2x plus 4y equals 12. So then that one is ready to be stacked for systems. This one I need to move, I'm going to move the 1 first. 3y equals 4x minus 1. And then I'm going to move my 4x, x, which turns into a negative 4x plus 3y equals negative 1. Now we're going to stack those two equations on top of each other, and we're going to solve this system. So I'm going to say 2x plus 4y equals 12, and then negative 4x plus 3y equals negative 1. Now recall, for an elimination problem, we're trying to get rid of either the x's or the y's using zero pairs. 2 and negative 4 could become a zero pair quickly if I multiply, I think I dropped a negative. I did. Let me pick it back up. This is a negative 2x. I apologize. I subtracted 2x but forgot to bring it down. So that means that this guy down here, let me fix that. This is a negative 2x. And then we've got our, now I'm good. I think I'm good now. Yeah, just checking. Sorry about that. And then we've got our negative 4x plus 3y. Okay, we're good. Sorry. I just want to make sure that we're in the right spot. So now if I want to make those become a zero pair, I can multiply this equation by a negative 2 in order to get negative 2 times a negative 2 to become a positive 4 to cancel this. So I'm going to come over here. Negative 2 times negative 2 is a positive 4x. Negative 2 times 4y is negative 8y's. And negative 2 times 12 is negative 24. The bottom equation stayed the same, so negative 4x plus 3y equals negative 1. And now we're ready to eliminate. So now I eliminate the 4x's. Negative 8 plus 3y is a negative 5y's. And then negative 24 minus 1 is negative 25, more negatives. Divided by negative 5, and y equals positive 5. Now finally we plug that back into one of our friendly equations. I think I'll use, I don't know, let's do the bottom one because it's slightly smaller numbers. So negative 4x plus 3 times 5 equals negative 1. Negative 4x plus 15 equals negative 1. And then minus 15. Negative 4x equals negative 16 divided by negative 4, and x equals 4. Thank you.